Hi, welcome to EveMath. If you're watching this video right now, please watch it to the end so you get the full grasp of it. Leave a comment or like this video and subscribe to my channel for new calculus problems. Okay, so here we're facing a limit. The limit that we're facing is the limit as x goes to infinity of x squared over e to the 4x minus 1 minus 4x. Okay, to solve this limit, okay, firstly, you need to do it yourself and see if you can come up with the answer. Pause the video and try to do it yourself. Okay, so to solve this limit, let's analyze the behavior of both the numerator and the denominator as x approaches infinity. Okay, so if we analyze the numerator here, we know that x squared, is a polynomial, right? We know that x squared is a polynomial, and e to the 4x in the denominator, it is the exponential function, right? This is an exponential. Good. Now that we've said that, the numerator x squared, as x approaches infinity, x squared also approaches infinity, but at a relatively slower rate compared to exponential functions. Okay, a polynomial function in general is going to be large number, but at a slower rate as compared to an exponential function. An exponential function is a very big number. So given that it is not a decaying one, but an exponential function that increases. Yeah. So if we do the denominator part, the denominator is e to the 4x minus 1 minus 4x. Okay. Let's break this down. E to the 4x grows extremely rapidly as x approaches infinity because exponential functions increase much faster than polynomial functions, as we've said, right? The terms -1 and -4x will become negligible compared to e to the 4x. These two terms right here, -1 and -4x, we can neglect them. We can neglect these terms. Why? Because they are extremely smaller numbers as compared to e to the 4x. If as x approaches infinity, if you put in infinity in the place of x in the denominator, 4x is going to increase by relatively slower than e to the 4x. That's why we neglect -1 and -4x. All right. If we do that, the denominator for larger x can be approximated as e to the 4x. We can now rewrite the denominator as e to the 4x if we neglect -1 and -4x. Now the new limit is in our problem, it's going to be the limit as x goes to infinity of x squared divided by e to the 4x. We first deal with those little things, the -1 and -4x, that is going to cause us problems. Now the new limit now is going to be the limit as x goes to infinity of x squared divided by e to the 4x. I hope you're still following. Right. Now we're having a new problem. The limit goes to infinity, as x goes to infinity, of x squared divided by e to the 4x. Now, the simplification as it goes to this part, consider the growth rates. Now, if we focus on x squared grows polynomially, we said it, while e to the 4x grows exponentially, right? The exponential function dominates the polynomial function as x approaches infinity. e to the 4x will dominate x squared when it comes to increasing. Yes, x squared is going to increase if you substitute infinity, but it will increase at a slower rate than e to the 4x. It's more like we represent it like this. This represents x squared over this represents e to the 4x. e to the 4x. This is going to be x squared. Sorry, it's going to be x squared. Yeah. This is how they grow. the comparison. Therefore, the fraction x squared over e to the 4x will approach 0 as x approaches infinity. This gives us the final answer. The limit is going to be equal to 0. The final answer is going to be equal to 0. Why? Because the denominator's exponential growth, it will outpace the numerator's polynomial growth, making the overall fraction shrink towards 0 as x becomes very, very large, right? So that's why the answer is going to be 0. So I hope you're still following why we get the final answer of the limit to be equal to 0. Any number, for example, let's just try and say x was, let's say x was 10,000. If x was 10,000, if we substitute back into the formula, the new formula of x squared over e to the 4x, this will be 10,000 all squared divided by e to the power 4 times 10,000. The number in the denominator is very large, but the number in the numerator is also large, but as compared to the denominator, it's extremely smaller. Therefore, this whole number is going to approach 0. Any number that is high in the numerator and big in the denominator, that number approaches 0. If you press this number in the calculator, it will actually get closer and closer and closer to 0. If you increase the number x, if maybe you'd say 100,000, the calculator's gonna be giving you big numbers. I mean, very, very, very small numbers. Yeah, that approaches 0. I'm sorry. Yeah,